Okay, welcome to Chapter 7. This will hopefully be a review on arrays. So an array gives you the opportunity to store multiple items of the same data type. So if I wanted to store all of the grades for all the students in this class or all the test scores, instead of declaring 75 or 150 different doubles, I can declare one array called test scores and make it of size 150. And that way I could keep 150 doubles in one altogether in memory. Also, when I declare an array, I do get a piece of memory. So when I declare an array, we'll just use 20 now. When this array gets declared double test scores of size 20, your program, your computer will allocate 20 doubles in memory for you to utilize. So that's a very important thing to realize. Once I have declared the test scores, then I am able to access each one, and each item within that, starting at index 0, is its own double, starting with test scores at index 0, all the way up through test scores at index 19. Here's an integer example right here. This is declaring an array of 5 integers, and there are the 5 integers that you can utilize are score at index 0, score at index 1, all the way through score at index 4. These variables are integers. So once you've declared an array, each element within your array, you can use the same way that you use any other element of that data type. So here's just a code. Here's an example of code, which is, we're going to put this in the compiler. This declares an array of size 5 integers. We also have we're going to find the maximum of those. So right here, we need to ask the user. So here I want to ask the user. So here we say enter 5 scores, but I'm going to also add here so I get 1 score at a time. Enter a score. I don't really like to say enter 5 scores and then get 5 scores. I like to, so we're going to loop. We're going to get the first score into score at index 0 here, and then that's going to be assigned to be the maximum value, and then we're going to get 4 more scores starting at score at index 1 up through score at index 4, and we're going to find which one is the maximum. And this right here is a loop that's going to print out the scores and how far they are off by the maximum. So let's test it. I do believe we already did this in class, so that's why I'm just kind of rushing through this. Enter a score, 23, 12, 45, 66, and 1. So the highest is 66, and this tells us how far off it is from max. So one thing I want to point out here is that if we have an array called scores that stores 5 integers, and we're going to fill that entire array, so we're not keeping a count in this one, but mostly if we do have an array, we will use what's called partially filled arrays, and I have more examples on that. And a partially filled array allows you to declare an array larger than what you need, and then you just have to keep count or keep track of how many elements are in that array. And then later in chapter 8, or chapter 9, we will get into dynamic arrays. So here is a loop. If we have 5 elements in our array, this is a loop which is going to start at the beginning of our array, go less than 5, so that would go 0, 1, 2, 3, 4, and go up by 1. So if we wanted to fill the array one by one, if we wanted to print the array elements onto the screen, if we wanted to do some calculations with every element in the array, if we wanted to search through the array, this for loop right here is the one that would be used. And you can also do the same thing with a while loop, but for my examples, I'm going to make it easier and stick with a for loop. But there's no problem if you would like to use a while loop to go through your arrays. All right, let's get back to our notes here. All right, so one thing to keep in mind is that arrays are stored in memory consecutively. So what that means is when you declare an array of size 6, you get 6 integers starting from the address where A begins. You get 6 integers in a row stored in memory. And this is an important thing to realize, because if you try to access, say, A at index 8, the way that your computer goes to access that, it will start at index 0 and count that many integers until it gets to index 8. And as you can see by this right here, that there would be no index 8. The highest index in this situation would be a 5. All right, initializing arrays. So there's a couple of ways to initialize an array. When you declare an array of size 3, you can fill it with elements separated by commas. So this is an array called children of size 3, and these, I guess, are the ages, and there are 3 integers in that array, and we are assigning it. If you do not give a size to your array and you just declare it this way, it will automatically be sized by the initialization. Now, one thing you cannot do with arrays is you cannot declare an array and then later try to assign values to it. You have to assign the values at declaration and initialization. Those have to be done all in one statement. If I later want to assign values to my array, I will need to assign the items to my array one by one. All right, so this is an example of another way to use the C++ range-based for loop to traverse through an array. I'm going to stick with the standard way, but it's certainly okay in this class if you would like to use the C++11 way to go around an array. There's an example on Canvas of this. It's called Chapter 7 for loop. All right, let's talk about arrays and functions. So here's a function. This is a function prototype. This function is called myFunction. It has a void return type, and the type of data that it takes is an integer. And below it, I've declared one integer called n and initialize it to the value 10. This integer parameter right here is a pass by value parameter. That means that if I want to pass an integer to this function, my integer must have, if I want to pass an integer variable to the function, my integer variable must have a value in it. It's a pass by value parameter. The other, so let's take a look at this. So the first thing I have here is an integer, just a plain integer that's been initialized to the value 10. So I can pass, once this, if I want to call that function, once n has been declared and assigned the value 10, n can then be passed to the function because it has a value. Also, that's this line right here. I could also just pass a literal 25 to this function. Now, hopefully you guys understand that if it's a pass by reference, you cannot pass a literal value to a pass by reference parameter. Each element in the array, once an array has been declared, every element in the array will become an item of that data type. So once I declare int array of size 3, I have 3 integers that I can use. I have array at index 0, array at index 1, and array at index 2. And since I've assigned values to them, I can pass them with a pass by value. So array at index 1, which actually has the value of 3, would be passed to that function, and that's a legal call to that function. So anytime that any element within the array, if it's a pass by value, it must have a value in order to be passed to the function. And if it's a pass by reference, you can use it just like any other integer as long as it's in the range of the array. All right, so now let's move on to this next example. We have 2 functions here. The first function is going to fill up an array, and it's going to get the count as a pass by value parameter, and it's going to get the count before it calls the fill up function, and then after the array will be full. arrays, when you pass them, are automatically passed by reference. Arrays are pointers, which means that if an array is passed to a function, that array can be modified within the function. If you do not want your array to be modified within the function, then you can use const to prevent your array from being modified. That stands for constant. And that means, as you can see here, if I'm filling the array is going to be modified inside the function, but if I'm printing the array is not going to be modified inside the function. Jeez. So this is an example of a code that is on Canvas. The code on Canvas is called array functions. So we can take this into the compiler and take a look at it. So when you do have assignments, or if you want to practice, you have these examples on Canvas in order to practice. So this has two functions. The first function is called fill up. This function has a void return type. It takes two arguments. It has two formal parameters. The first is a pass by reference because it's an array of integers, and the second is a pass by value count. So count needs to have a value before the function is called. So let's take a look at it. Here's a function call to fill up, and here's the function call to print array. Print array is going to take the same array and the count, and it's going to print the elements onto the screen. I don't know if in a column. So here we are using what's called a partially filled array. The array is declared to be of size 50, and the user is going to say how many items they want to put into the array, but they must enter a number less than 50. And remember that the indexes of the array are 0 through 49. So here is the loop that goes through starting with 0 to 1 less than count. So say, for example, the user were to enter the number 30. They wanted to put 30 integers in the array. Then this loop will iterate 30 times, starting at 0 and going through 29. And the same loop is used to print the items in a column. So it would print the first number in the array and then a new line, and then the next number in the array and then a new line, and then the next number in the array and a new line. All right, so that's an example. This should definitely be review. If it is not review, please practice and take a look at this code. And I will be making another video in PowerPoint in which I will draw some pictures to help you guys to understand how arrays work. So I've already talked about partially filled arrays. Partially filled arrays are what we are using right now in this chapter, meaning we are going to make arrays larger than what we need. So if I wanted to do something for a class, a list of grades for the class, or a list of names of everyone in the class, since I have approximately 150 students, I would make my array at least size 150, and then I would do the actual count of my students and make the count be that many students. It's important to remember that every time when you're using partially filled arrays, whether it's an array of strings, an array of doubles, or an array of integers, you need to be sure to use an integer to keep track of how many elements are in there. So when you declare here, I declare an array of numbers. This is my array of size 50, but then I also keep a count, which in this case it's called n, but I could call it count. I have an integer that keeps track of how many numbers are actually in there. So even if it were an array of strings, you would do the same thing. You would declare an array of strings, and then you would keep track of how many are in there. So just make sure that you make your arrays larger than what you need.